Now starting chapter 15, we're going to talk more about conditional probability next time. This is kind of the easy form of conditional probability, a little review of two-way tables from chapter 4. So sometimes the knowledge that one event has occurred changes the probability that another event will occur. In this case, the events are not independent. Okay, like drawing cards from a deck of cards. Okay, if I draw 2 cards off, the second card doesn't have the same probability of being a black card as the first one did, because I've reduced the number of cards in the deck. So your estimate of probability of being in a car accident increases if you know that it is raining outside. Okay, it's a fact. Long run probability, more accidents happen in the rain. Okay, so if you know that it's raining, the probability of you being in an accident is higher. Your parents are right when they get nervous about things like you going out in the snow and in the rain. All right, suppose that the pass rate on an AP statistics exam is 80%. That is, for a randomly selected student, the probability that you pass is 80%. However, if you know the student got a B in the class, the probability increases to 95%. That is, for a randomly selected student, the probability that you pass, given that you have a B, is 0.95. Okay, now this is an example of a conditional probability right here. Okay, this is the notation or the way we write a conditional probability right here. The probability that you pass, this slash is read given that you got a B in the class. So here's the deal. Listen up. Conditional probabilities are probabilities that look like I have a slash in the problem. They're probabilities that you're always asked to find the probability of the first thing. So find the probability that you pass. But here's a little secret. Here's something I already know about this thing. Okay? Find the probability that you pass, but here's a little something I already know. This little something that you already know may or may not change this probability. But a lot of times it does. Okay, so a conditional probability, it has a condition, something that already exists. Okay, so probabilities in this form, A/B, are called conditional probabilities. And they're pronounced, the way you read that problem, just like I said before, the probability of A given that B has already occurred. Probability that A happens given that I already know that B happened. B is a fact. So, the following data, we're going to use this to answer a whole bunch of questions on the next page. Following data is about 2,201 passengers on the Titanic. 367 of those were males that survived. So, in other words, 367 out of 1,731 males survived. So this would be the number that survived. That number on the bottom would be the total number of males. And overall, 711 survived. It says express this in a two-way table with gender and survival as the variables. So review. A two-way table is a way to summarize the relationship between two categorical variables. It lists the outcomes of one variable down the left side. So let's say we can list gender here. And the outcomes of the other variable across the top. So let's call this survival. So what are the options for survival? What? You either survived or you did what? You died. Okay, so what about gender? What are your options for gender here? Male or female? So gender, you could have been a male or you could have been a female. Okay, so now these extra things here, what is this going to be? Everything here. What's this number going to be? Not exactly, but in general. Who can tell me what all these numbers on the outside are going to be? Totals. Very good. They're all totals. So this is what's this the total of? Total survived. This down here would be the total that survived. Okay, how about down here? What's this? Total that died. Okay, how about over here? What's this total? Total male. Right below it. Total female. Okay, down in the bottom. Yep, grand total. How many were on the Titanic? It says, right, in this paragraph that I'm circling gives you all the information you need to fill every single spot in there. How many people were on the Titanic? 2201. How many people were male? 1,731. How many males survived? 367. How many, let's see, how many total survived? 711. That's all I know. Subtraction is all we have to use. So all we have to use is addition and subtraction to fill these in. So here, these two have to add up to this. Down the columns have to add up to the bottom. Across here has to add up to 2201. The overall distribution for gender is called the marginal distribution of gender. The distribution for a specific gender category is called a conditional distribution. Now, what we did with these things before, back in chapter 4, was we made segmented bar charts. We might have taken something like males and females and made a separate bar for each of them. And then within the bar, we would say, well, each bar represents 100% of the males and females. And like we would say, okay, of the females, how many females survived? What percent of them? So I take 344 divided by 470. So actually 73% of the females survived. That's pretty big. So 27% died. So for the males, if I find the percent that survived, it was only 21% survived. And that would mean that 79% died. Okay, so the question that we would have answered was, is gender independent of survival? No, it's definitely not. The time you would say it's independent, remember, if the bars looked exactly the same, then they're independent. So gender is not independent of survival. And the reason is because the bars are so different. In other words, if I told you that I was a female on the Titanic, you probably would have guessed that I survived. Okay, you can guess what happened to them based on their gender, and that means they're not independent. All right, well, that's not really what we're doing today. What we're going to do today is we're going to find probabilities based on this probability, this two-way table that we just made. All right, so we're just going to start by answering some of these questions. So the first one is, what is the probability that I survived? Sorry. Probability that I survived? Well, since I'm just asking out of the grand total, so out of the 2201, how many survived? 711. Okay, that's pretty easy. Okay, now what probability were male? So out of the 2201, how many were male? 367. Okay, now this is an and probability. So the and probability is still out of 2201. And probability is still out of 2201. But now we're going to kind of narrow it down. We're saying female and survived. So instead of looking in one of these margins, we need to look inside here. So the probability that they were female and they survived, well, find where female and survived meet. That would be 344 out of 2201. Okay, so the next one, female or survived. Remember, this little thing means and the U means or. That's what you got to remember. So or is still out of 2201, okay? But we might have to think a little bit about this. So out of 2201, how many were female? 470. Plus, or plus, how many survived? 711. But can you be a female and survive at the same time? So don't I need to get rid of how many females, if you were a female and you survived? So how many females survived? How many females survived? 344. See, because that's the general addition rule, because I actually counted them twice. Okay, I counted the females who survived here, and I counted them here. So I have to subtract them out. So I need to take 470 plus 711 and subtract 344. So that would give me 837 over 2201. All right, now the next 5 are what types of probabilities? Conditional probabilities. So conditional probabilities are really nice because this second thing is the condition. That's what I already know that happened. So I'm finding the first probability, and the second thing is going to narrow me down to a row, a column, or a row. So the second thing is actually going to lower my total from 2201 to one of these 4. So a conditional probability is easily found on a two-way table if you realize the second thing, the condition, is eliminating part of the total for you. It's making it easier. So what's the probability that you survived given that you were female? So if I know I'm female, how many females am I dealing with? 470. Okay, so knowing that I'm a female means I'm only dealing with 470 of them. Of those, so basically it gets me into this row that's all females. So how many survived? 344. And there we go. Notice I'm not worrying about reducing these or anything. All right, male, given that I survived. So row or column, what row or column do I look in? Survived. I narrow it down to out of how many survived. How many survived? 711. How many of those were male? Tell me. 367. Thank you. So the second thing narrows me down to a row or column total, and then the top is just how many in that column were the first thing. So female. How many were female? 470. How many of those females died? 126. Okay, now it's the other way around kind of. How many died? 1490. How many were female? 126. So the second thing gets you to the row or column, write that total down, look at the first thing in that row or column, that goes on top. So, out of how many people survived? How many people survived? How many were female? 344. Okay, so now we're going to get the general multiplication rule. It says the conditional probability of event E and F, given that event F has occurred, is the probability of E given that event F has occurred